All right, so your quiz tomorrow is on 7.1 to 7.3. It's 8 questions. A lot of the stuff that's on your review is on your quiz. You're going to have to find the square root, the cube root, the root of a fraction, add, subtract, multiply, binomials that have to deal with radicals. Bless you. And then rewrite radical expressions as expressions raised to an exponential, like a rational exponent. Okay, so we're going to start with just finding the square roots, cube roots of things. So for number 1, you have the square root of 64. If you didn't know off the top of your head that the square root of 64 is 8, you can break this down. Again, if you didn't know 8 goes into it evenly, you can divide it by 2. The 2 goes into 6 3 times. 2 goes into 4 2 times. The 32 is 4 and 8. 4 is 2 and 2. 8 is 2 and 4. 4 is 2 and 2. So when we look at the index, which we don't have, it's understood that it's a 2 since we're taking the square root. So you're going to group up sets of 2. So you have 2 2s here, 2 2s here, and 2 here. You have 3 sets there. So for each set, you're going to pull out one of those numbers to represent the set and multiply all the numbers together. So 2 times 2 times 2 is 8. The square root of 64 is just 8. So if you don't know off the top of your head, find the prime factorization of the number underneath the radical, and then group up based off of the index. If there isn't an index, it's understood that it's 2, so use that in order to group up the same amount or the same number of terms. For number 2, you are working with the cube root of negative 27. So because there's a negative underneath this cube root and that index is odd, you're going to include that negative in your answer. 27 is 3 and 9. 9 is 3 and 3. We're working with groups of 3. You have 3 3s. Remember, your answer has to be negative, so it's going to be negative 3. For number 3, you have the square root of 120. So for this one, that 120 breaks down to be 12 and 10. 12 is 3 and 4. 4 is 2 and 2. That 10 is 2 and 5. So this is taking this square root. You're looking for groups of 2. You have 2 2s. You pull 1 out. The 3 does not match up with another 3, so it stays under. The 2 does not match up with another 2, so that stays under. And the 5 does not match up with another 5, so that stays under. Multiply everything underneath. 2 is on the outside. You are left with the square root of 3 times 2, which is 6, times 5, which is 30. So it's just 2 square root 30. For number 4, you're working with the cube root of 56. We know that 56 is 8 times 7. 7 is a prime number, but 8 breaks down to be 2 and 4. And that 4 breaks down to be 2 and 2. You're taking the cube root, so you're looking for a set of 3 of the same number. You have 3 2s, 1 comes out. That 7 doesn't match up with another 2 7s, so it stays under the cube root. Make sure that when that 7 stays underneath that cube root, you indicate that it is the cube root. If you don't, and you just write the square root, it is considered a different answer. So make sure that that root or that index is there. For number 5, you have the square root of 12x to the 7th power. We're working now with variables underneath these radicals. So remember, when that happens, you're going to take the power that's on that variable and divide it by the index. Whatever's left over, or the remainder part, is going to stay underneath the radical. Whatever simplifies goes on the outside. So with this one, our index is 2. So we're going to find the prime factorization of 12. We're going to also divide the 7 by 2. So this 12 is 2 and 6. 6 is 2 and 3. We're looking for groups of 2. The 2 2s pair up, so 1 comes out. That x to the 7th power divided by 2 gives you x to the power of 3 with a remainder of 1. So that x cubed is going to go on the outside, and then the x to the first power is going to stay underneath. So what you have underneath is the 3 and the 1x. So that's going to be 2x cubed times the square root of 3x. For number 6, we have the cube root of 24a cubed b to the 13th power. So that 24, we're going to find your prime factorization of it. 24 is 4 and 6, 4 is 2 and 2, 6 is 2 and 3. We're going to take that a cubed, divide the cubed by the index, which is 3, and that b to the 13th power, divide the 13 by the index, which is 3. Your 3 2's group up. You're going to take 1 out, the 3 stays underneath. The a to the 3rd power divided by the power of 3 is just a to the 1st power, so that goes out. And that b to the 13th power divided by the 3rd power is going to be b to the 4th power with a remainder of 1. So b to the 4th power comes out. The 1b is left over, the 3 is left over, so it stays underneath the cube root to give us 2ab to the 4th power times the cube root of 3b. For our next question, number 7, we have the square root of w over 16. This is the same exact thing as saying take the square root of w over the square root of 16. We can't take the square root of w, so it's going to stay the square root of w. However, the square root of 16 is 4, so that's the square root of w over 4. For number 8, you have the square root of 8x cubed over 9. So again, this is the same thing as saying take the square root of 8x cubed over the square root of 9. We know that the square root of 9 is 3, so you can simplify that one first. Up top, though, that 8 is 2 and 4. 4 is 2 and 2. We're working with square roots, so a 2 comes out, a 2 stays under. That x cubed, divide the cubed by 2, that's going to give you 1x with 1 left over. So underneath, you're going to have a 2 and an x. Outside, you're going to have a 2 and an x. And the denominator is just 3. So it's just 2x times the square root of 2x over 3. If we look at number 9, we're given 81 to the power of 1/2. For this one, we are going to rewrite this 81 to the power of 1/2 as a radical. Your power is coming from your numerator. Your index comes from your denominator. So this is saying to take the square root of 81. We can simplify this so that 81 is 9 times 9. You have a set of 2 9s, so those pair up. And the square root of 81 is just 9. For number 10, you have 100 to the power of 3 over 2. So again, that numerator is your power. The denominator is your index. So it's saying to take the square root of 100 raised to the 3rd power. So the square root of 100, you have 10 times 10. So that's just 10 to the 3rd power, which is 1,000. For number 11, you have negative 16 to the power of 3/2. Now, this negative 16 is the opposite of 16 to the power of 3/2. So that means that you would literally have parentheses around that 16 to the power of 3/2. That negative is not attached to the 16. So do what you have to do with that 3/2 to just the 16 first. If it was attached to the 16, that negative, the entire thing would be in parentheses. Okay, so that's 2 different things. Make sure you're aware of that because you're going to definitely see that tomorrow. So again, that negative is not in parentheses with the 16, so you can treat this as the opposite of whatever 16 to the power of 3 over 2 is. The 3 is going to be your power, the 2 is your index, so this is the opposite of the square root of 16 to the power of 3. So follow your order of operations. The square root of 16 is 4, so that's the opposite of 4 to the 3rd power. You do your exponent first before you multiply. 4 to the 3rd power is 64, so that's the opposite of 64, which is just negative 64. So again, remember, if this was parentheses, negative 16, close parentheses, then raised to the 3/2 power, that's different than what this is. If that was the case, then that negative would be underneath the radical with the 16. For number 12, you have 5 to the power of 1/3 over 5 to the power of negative 2/3, all raised to the negative 3rd power. Follow your rules with exponents. When you have the same base and it's on the top and the bottom of your fraction, subtract those powers. So this is going to be the same thing as saying 5 to the power of 1/3 minus the power of 2/3, all raised to the negative third power. Minus the power of negative 2/3, sorry, because this is a negative 2/3. So your double negatives turn into positives. You add the 1/3 and the 2/3 to give you 5 to the power of 3/3, all raised to the negative third power. 3/3 is the same exact thing as 1, so that's 5 to the first power to the negative 3. You multiply your powers here, so that's going to be 5 to the negative third power, and you simplify that negative power. Because that power is negative, take the reciprocal of the term that it's attached to. So that's going to be 1/5 to the third power. That 5 to the third power gives you 125, so this is just 1/125. If we look at number 13, you have 2 square root 3 minus 5 square root 6 minus 4 square root 3 plus the square root of 6. Number 1, that square root of 6 that's last does not have a number in front of it, so it's like there's an imaginary 1 in front of it. In order for you to add or subtract these radicals, you need to make sure that your index and the number underneath the radical are identically the same in order for you to combine what's in front. So if you look at your like terms, your 2 square root 3 is a like term to the 4, or the negative 4 square root 3. Your negative 5 square root 6 is a like term to the 1 square root 6. So keep the radical part, but add or subtract what's in front. So we work with those square root 3's first. 2 square root 3 minus 4 square root 3 is negative 2 square root 3. And then that negative 5 square root 6 plus 1 square root 6 gives us negative 4 square root 6. If you had to simplify those radicals, you would do so as well. You cannot simplify the square root of 3, nor can you simplify the square root of 2, so that's why it's left with those radicals. For 14, you have 9 square root 20 minus 3 square root 45. That square root of 20 and that square root of 45 both need to simplify. So 20 is 2 and 10. 10 is 2 and 5. Your two 2's pair up. So that's like saying 9 times 2 square root 5. With that square root of 45, that needs to simplify as well. 45 is 5 times 9. 9 is 3 times 3. Your two 3's pair up. So that's like saying negative 3 times 3 square root 5. From here, your 9 and your 2 are going to multiply, as well as your negative 3 and your 3. So 9 times 2 gives you 18 square root 5. Negative 3 times 3 gives you negative 9 square root 5. If you have like terms, you combine them. In this case, you do have like terms because they both have the square root of 5 attached to them. So 18 minus 9 gives you 9. You keep the square root of 5. So it's just 9 square root 5. For 15, you have 3 square root 10 times 2 square root 14. That square root of 10 does not simplify because it's just 2 and 5. The square root of 14, again, does not simplify, but it's 2 and 7. Instead of multiplying the 10 and the 14, what I would do, I would multiply what's on the outside, so the 3 and the 2 multiply together. Underneath, we said the 10 was 2 and 5. The 14 is 2 and 7. So group up sets of 2 of the same number since we're working with a square root. The 2 groups up with a 2. So you pull the 2 out as well. So it's going to be 3 times 2 times 2 times the square root of 5 times 7. From here, the 3 times 2 is 6, times 2 is 12. The square root of 5 times 7 is the square root of 35. So that's just 12 square root 35. For 16, you have 8 plus the square root of 10 times 8 minus the square root of 10. For the purpose of tomorrow, because when you have two binomials that are multiplied by one another that include radicals that are not in the form of this, so they're not the same two terms with opposite signs in between them, we are going to FOIL. You're going to do the 8 times 8, which is 64. The 8 times the negative square root 10 is negative 8 square root 10. The square root of 10 times 8 is positive 8 square root 10. And the square root of 10 times negative square root 10 is a negative square root 10 times 10. From here, your like terms are the negative 8 square root 10 and the positive 8 square root 10, so you combine them. They cancel each other out. The square root of 10 times 10, your two 10s pair up, so you're going to pull the 10 out. So it's going to be 64 minus 10, which is just 54. For the last one that we're going to go over, you have the cube root of 8x to the 5th power plus the cube root of 27x to the 5th power. Remember with these, that 8 you can break up as 2 and 4. The 4 is 2 and 2. So you're grouping up sets of 3 because your index is 3. You have 3 2's, so that 2 comes out. That x to the 5th power, you're going to divide that by 3. So that's going to give you x to the 1st power with a remainder of 2. So when x comes out, an x to squared stays under. So that gives you 2x cube root x squared. For the cube root of 27, x to the 5th power. That 27 is 3 and 9. 9 is 3 and 3. So again, you're grouping up sets of 3. That gives you 3 on the outside. That x to the 5th power, again, we divide that power by 3 since your index is 3. That gives you x to the 1st power with a remainder of 2. So when x comes out, the x squared stays under. From here, check to see if you have like terms. If you do, combine. You have an x squared underneath the cube root for the first term. Second term, you also have the cube root of x squared. So because these indexes and what's underneath the radical are the same for both terms, add what's in front. 3x plus 2x gives us 5x. Then you keep the cube root of x squared.